In this next part of the production possibility frontier and trade section, we're going to hit the main point. All right, we've got our basic model of production possibility frontier for a farmer. Now let's bring it together and move to two farmers, right? So this is where we think about two different economies. So again, if we think about a really small scale, we can think about a farmer as being an economic unit. And we've already got this punchline that between me and my fictional neighbor kid, Ryan, that trade is a good thing. So that's going to be the point of this. To get there, let's talk through two farmers. We've got farmer A who can produce corn and soybeans just like before. Notice that the numbers there should all look familiar. But now we're adding to the story farmer B who can also use his time, talent, and energy to produce corn or soybeans. And take real quick for a second, notice some of those numbers. And my question for you is, what kind of, in your own words, how would you describe the differences between these two farmers in terms of what they can produce and their different abilities and what that might mean in terms of their resources and technology? Okay, so step one, let's go ahead and graph this story out. So farmer A, we know that his production possibility frontier, when we do corn on the vertical axis, what did it start with? It started at 500, and I'm going to try to be a little careful with this and put 500 up here, and I'm going to have it be a line that goes down to 300, or not 300, 200, and so I'm going to try to draw it right here for 200. Do this little equation. Could you come up with a line, or not a line, but an equation that described this farmer A's production possibility frontier? You should be able to, right? We did it in the last video, so look for that for some review. Again, it looks something like C equals negative 2.5 S plus 500. Go ahead and verify that that's the correct equation. Now let's add to the story farmer B and his production possibility frontier. So again, this is why I wanted to be a little bit careful. So yep, farmer B's vertical intercept is now 900. Oh my goodness, I wasn't careful enough. It needs to be way, way, way up here, and it probably actually should be a little bit higher, right? Because it's higher than farmer A's vertical intercept. Think about what that might represent again. All right, now farmer B, what is his horizontal intercept? He has a horizontal intercept of 300. So his is somewhere, let's do it about here, and hopefully when I'm looking at the size of this 200 relative to the size of this 300, hopefully that's about right. Farmer B also, if you glance down the list, notice that the rate of change between the lines for corn and soybean also is constant for farmer B, meaning that he also has a straight line. So hopefully it looks something like this. Again, are you able to come up with an equation that describes this farmer B's production possibility frontier? Again, reference the earlier video if you need a little bit more help doing that. But his production possibility frontier equation should be C equals 900 minus 3S. Again, go ahead and verify that that's the correct equation that describes this. Now what I want you to do is I want you to consider these points. Right? So I've got these points. For farmer A, the convention that I'm using is that the thing I'm measuring horizontally is going to be first. So that's 150 units of soybean and 145 units of corn. Where would that point be? In order to find that out, it's helpful to have this equation, right? So if this equation describes this line, this point that I'm asking for has 150 soybeans. Let's go ahead and put that value of soybeans into this equation. 2.5 times 150 plus 500. And let's bring that calculator up just to make sure that I don't mess up this equation again. Right, so we've got negative 2.5 times 150. Oh, I said that wrong. It is negative 2.5 times 150. There we go. Right, so 2.5 times 150 equals 375, and that's negative. Oops, that's not how I do the negative on this guy. How do I use this online calculator thing? This is not a very great one. This is the negative 375, and then the vertical intercept was 500, so it's 500 minus that 375. What the equation tells me is that at that amount of soybeans, when soybeans are 150, the point on the line is 125. But the point I asked you to find was corn equals 145. So that point is where? It's outside of the production possibility frontier. And remember, what's the name that we call for points that are outside the production possibility frontier curve? Right? Now, can you find the other point that I'm asking you to find with this combination? For farmer B, 50 units of soybeans. Geez, that's not that much soybeans. And 755 units of corn. Again, use that equation first. If we plug 50 for soybeans into this equation, that's minus 150. So 900 minus 150 is going to be 750. Right? Double check that math. And the point that I asked you to identify was also a point that's a little bit outside of the production possibility frontier at 755. So what we've identified is we've identified this combination, right, that's impossible, it's infeasible. Neither of those points can be achieved unless, remember our two criteria, unless, number one, these farmers have more resources, but resources cost money, or these farmers had more technology, but acquiring technology often costs more money. Okay, there's going to be a third way that the farmers can achieve those impossible or infeasible points. Before we get there, though, we want to introduce two new terms. We're going to talk about these two different farmers and their potential advantages, right? We've got two terms, absolute advantage and comparative advantage, right? So simplification of the way that economic history is developed is we've got this guy, Adam Smith, right? And Adam Smith writes this big book, The Wealth of Nations, and in that book he makes this argument for nations trading with each other as a way to generate some wealth. But fundamentally, a lot of his argument rests on this thing called absolute advantage. Definition: an absolute advantage is the side that can produce more of a good. So here's the way I would ask the question. For an absolute advantage, which of these farmers has an absolute advantage in producing corn? What I'm really asking is, between these two farmers, which of these farmers can produce more corn? We look at the intercepts, and for farmer A, if he's only producing, using all of his time, talent, and energy producing corn, farmer B, using all of his time, talent, and energy producing corn, who can produce more corn? Farmer B can. Yep. How about an absolute advantage in producing soybeans? Let's look at the soybean intercept. And farmer B also has the absolute advantage in producing soybeans. Farmer B is just better at producing soybean, and he's also better at producing corn. This is kind of like the U.S. as we consider one of our smaller trading partners, right? Like a small country like Honduras, right? We've got more land, labor, and capital. We've got more resources. We've got more technology. We can produce more of any other good than that country. Does that mean we shouldn't trade with them? That gets complicated, right? Adam Smith says countries should trade according to what they have as an absolute advantage. After that, this guy David Ricardo came along and he made a much more satisfying argument for trade that was based on this concept of comparative advantage. Comparative advantage is, as you can see the definition there, it looks very similar to the absolute advantage definition. It's got one word that's different, the word relatively, right? So to look at a comparative advantage, you don't look at how much you can produce, but you look at relatively how much you can produce. We want to compare how much farmer B can produce of a good relative to the other good, and how does that stack up with the other farmer. And here's the decision rule for trading according to David Ricardo. The economy, or in this case farmer, who has the lower opportunity cost is said to have the comparative advantage. Whichever side has the lower opportunity cost is said to have a comparative advantage. Okay, so to get to that point, let's trace out a little bit of math here. So we've got two different farmers, and we've got the two different goods, and as we calculated in the last section, right, we can calculate either the opportunity cost of corn or the opportunity cost of soybeans. Notice what I'm doing here is I've got a little subscript there that represents whether it should be farmer A or farmer B? So I'm going to do this real quick, and then I want you to, on your own, verify that these numbers are correct. So for farmer A's opportunity cost of corn, it's equal to how much soybean he can give up per unit of corn. So for farmer A, I look at, all right, if he's going to give up some soybeans, he's going to give up 50 units of soybeans in exchange for getting 125 units of corn. And so that's a negative here, but I take the absolute value, so it all goes away. 50 divided by 125, yep, I remember that math. That was 0.4 units of soybean per corn. And the inverse of that, right, if I just take the inverse, remember that the opportunity costs of two different goods are inversely related to each other. It's just the inverse, right? Opportunity of corn has soybeans in the numerator. Opportunity of soybeans has corn in the numerator. So if I just flip this around, it's 125 units of corn per 50 units of soybeans. And again, I got that by looking at a one line to the next change in the table. That was, yep, that was the 2.5 units of corn per unit of soybeans. Now here's the tricky part, right? For farmer B, we haven't seen these numbers before. For farmer B, I was saying this earlier that you could go from one line to the next, but my goodness, because these production possibility frontiers are a straight line, you could actually go from the top of the list to the bottom of the list, and it makes the math pretty easy, right? So what do we have? If we go from the top of the list to the bottom of the list, farmer B is producing no corn, only soybeans. This is saying, what if farmer B wanted to produce some corn? If he jumped to the other extreme, he'd be able to produce 900 units of corn. But what would he give up, right? Remember, the opportunity cost is what he'd give up. He would give up 300 units of soybeans in order to produce his 900 units of corn. What's his cost of corn? He'd give up 3 soybeans per 9 units of corn. I should have simplified that a little bit further. That's 0.33 units of soybean per corn. And again, if we went the other direction, math is still the same, right? If he wanted to produce some soybeans, he'd have to give up some corn. If he wanted to produce some soybeans, he's going to give up some corn. He would give up 900 units of corn in order to produce 300 units of soybeans. He's going to give up 3 units of corn per unit of soybeans. So here we go. I've got 1, 2, 3, 4 opportunity costs, right? 2 producers, 2 different goods. I've got the opportunity cost. In the top, I'm looking at the opportunity cost of corn. So again, the decision rule according to David Ricardo was, who's got the lower opportunity cost? They're going to have the comparative advantage. We look at the opportunity cost of corn. Who has the lower opportunity cost? Same units. Look at the number in front. Who's got the lower one? Boom, right here. 0.33 is less than 0.4. We would say that farmer B has the comparative advantage in producing corn. If he wants to give up corn, he can do so at a lower cost. If farmer B wants to produce some corn, he can produce so at a lower cost. So up here, who has the comparative advantage in producing corn? That's farmer B. Notice that now we're going to move and ask the same question, but instead of producing corn, we're going to think about producing soybeans, right? Who can produce more soybeans? So this is the opportunity cost of producing soybeans between farmer A and farmer B. Who has a lower opportunity cost of producing soybeans? It's gotta be the other farmer, right? Remember, because these are inverse equations, right? Whatever we took here, we just flipped it on its head. So it must be, if this side has the lowest opportunity cost of this good, it must be that the other side has the lower opportunity cost of producing the other good. And that was really the genius that David Ricardo came up with. That yes, the US may be a bigger economy than Honduras, but when we have a relative advantage, when we have a comparative advantage in producing one thing, it must be that they have a relative or a comparative advantage in producing something else. They've got to be relatively better at it. And so that motivates a lot of the trade that builds on some of the work that Adam Smith did in a much more satisfying way, because it allows both sides to be good at something. Not absolutely, but relatively. Okay, so David Ricardo says step one to this whole process of David Ricardo doing trade is figure out who's better at doing what. David Ricardo, step one of trade, says who has a comparative advantage in producing a good. What we found out was that farmer B in blue has a comparative advantage in producing corn, and farmer A is relatively better, has a comparative advantage in producing soybeans. Step two, David Ricardo says, once you figure out what you are relatively good at, specialize in the thing that you're relatively good at. Specialize in the thing that you have a comparative advantage in. So here we go. We start with farmer A's production. If farmer A is going to specialize, what would they produce? I need to remind myself. Farmer A, they were relatively good at producing soybeans. So what if farmer A specialized? That is, that they took all of their time, talent, and energy and they just produced that thing that they're relatively good at, soybeans, right? It was soybeans, right? Soybeans, yes. If they only produce soybeans, how much corn are they going to produce? They'll produce no corn, but they'll produce 200 units of soybeans. That's farmer A's specialization according to his comparative advantage. How about farmer B? If he's going to specialize, what's his production? Well, he's going to specialize in the other thing, right? He's specializing in producing corn. So if farmer B only produces the thing that he is relatively good at, the thing that he has a comparative advantage in, he's going to produce 900 units of corn. And he's not going to produce any soybean whatsoever. So that's step two. Specialize. Specifically specialize in the thing that you have a comparative advantage in. Number three to this process, trade. Specifically, trade with others who are also specializing in the thing that they have a comparative advantage in. I'm going to propose a trade right now, right? So I'm going to propose between these two farmers. Farmer A only produces soybeans, but he might not want to have soybeans all the time. He might be willing to give up some soybeans in exchange for some corn. What's a good trade? Let's have farmer A trade away 50 soybeans in exchange for getting 145 units of corn. That's the proposed trade. If we have this proposed trade, we can think about what's going to happen. What's the allocation going to be after these farmers do the trade? So farmer A, he produced 200 soybeans, and if he trades away 50 of them, how many soybeans is he going to be left with? He'll be left with 150 soybeans. And in that trade, he gains 145 units of corn. That's what he's going to be left with after this trade. How about farmer B? After farmer B trades, let's see, he produces 900 units of corn, but he's going to trade away 145 of them. What's 900 minus 145? He's going to have left 755 units of corn, but in this trade, he's going to gain 50 units of soybeans. That in blue represents what they're going to end up with after they follow David Ricardo's advice, specialize in the thing that they are relatively good at, and then trade. Could we map out where those points would be, where these farmers are going to end up? If you're really, really careful, let's see, 150 soybeans, 145. Wait a minute, didn't we already... We did already map out these points. Aren't these actually the exact same points that we found earlier? What did we call them earlier when we couldn't find them, or when we found them on the production possibility frontiers? We said that those points were impossible. They were infeasible. You can't get there unless you have more resources or more technology, or if you trade. This is why economists love the idea of free trade, because what trade allowed these two farmers to do, it allowed them to expand, both of them, not just one, but both of them, to expand beyond their production possibility frontier without needing more resources, without needing more technology. All they had to do was engage in trade, and it made both sides of this transaction better off. That's the big punchline that David Ricardo has that's so powerful about this basic model. Trade, not more resources, not more technology, but free trade made both of these farmers better off. Okay, so one of the questions that I get oftentimes when I do this little section is, okay, they trade, but my goodness, in green, when you proposed that trade, how in the world did you come up with that trade that made both of these farmers better off? I want to point out one thing about this little proposed trade. Can we look at it as a ratio? 50 soybeans in exchange for 145 units of corn. Or alternatively, I could flip it on its head and I could put 145 units of corn per 50 units of soybeans. I do need a calculator. What's 50 divided by 145? Let's see. 50 divided by 145 is 0.34 soybeans per corn, or 145 divided by 50. I can't do that one in my head either. 145 divided by 50, 2.9. Corn per soybeans. I like this one a little bit better. 2.9 units of corn per soybean. That was the trade these two proposed. Flip back to the opportunity cost, and what do you notice, right? When we were considering the opportunity cost for these two farmers of producing soybeans, farmer A, who was good at it, had a lower cost. He could produce at a cost of 250. Or 2.5 units of corn per soybeans. Farmer B, he could produce, if he wanted to, he could produce soybeans, but his cost was going to be 3 units of corn per soybeans. What did they decide to do? They decided to trade at a rate that was somewhere between their two costs. They decided to trade at somewhere where at a point that was somewhere between their two costs. And that way, the one who was doing it was able to gain something from that, and the one who was not doing it was also gaining from it. He had a cost, but it was a lower cost than what he would have incurred if he had done it by himself. We can flip back and we could look at this ratio the other way, and it's the same story, right? But we're just using different numbers. 0.4, 0.33. Again, that's a value that's somewhere between those two. Notice, though, it's very much favoring the farmer A, right? Farmer A has this humongous gain from the trade, and farmer B has a gain from the trade, but it's not nearly as big. You could think about some of the factors that might influence whether a country gains a little bit or a lot from a trade, but again, the main point, trade made both of these traders better off. That's going to be true for individual traders. That's going to be true for entire countries. While we're here, we want to touch on one additional concept, right? So we talked about this story of the comparative advantage that used this relative measure of opportunity cost. I want to introduce this concept of relative prices as well, right? So we have a similar story in terms of prices. Normally, when you go in and you see a burrito on a menu, it'll have a price, $4. Pretty straightforward what that means to everyone, right? What we don't usually refer to that as, but what it actually is that what we see most of the time is called an absolute price. It's when we see the price of a good in terms of the currency we have to give up, right? So the $4, that represents the price, that's what we have to give up. If I was trying to write this a little bit more carefully, the way I would actually write this, the absolute price of a burrito, the price of a burrito is equal to $4 per burrito, right? The units are actually dollars per burrito. That's what I'm giving up per unit that I'm buying. Same thing for if I see running shoes, right? Running shoes are priced at $40. It's actually, if I was being really careful, the absolute price of running shoes would be $40 per burrito. Absolute prices are what we see most of the time, but relative prices are what we should be making good economic decisions on. Relative prices are the price of a good in terms of other goods, right? So the way that we calculate a relative price, the relative price of a good, I'm going to use an R as a superscript to designate relative price. The relative price of good X is equal to the absolute price of good X divided by the absolute price of good Y. So if we're doing this, right, let's go ahead down below and calculate the relative price of running shoes. The relative price of running shoes is the absolute price of running shoes divided by the absolute price of burritos, which, what we did earlier with this ridiculous way that you never see on a menu, but is actually the mathematically correct way to do the units, the relative or the absolute price of running shoes is $40 per running shoe, and the absolute price of a burrito is actually $4 per burrito. So mathematically, I can simplify this down, right? Numerically, I've got 40 divided by 4, 10, and this units, right? How do I simplify these units? Well, if I've got the fraction of two, or the ratio of two fractions, the way that I simplify that is I take my numerator, leave those units just the way they are, and then multiply by the inverse of the thing in the denominator. So I take the inverse, I flip it on its head, and notice that I've got some things that cancel out. My dollars cancel out, and what I'm left with, the relative price of running shoes. What's the relative price of running shoes? It's 10, and the units are burritos per running shoes. What does this represent? Relative prices represent, let's see, the relative price of running shoes is the price of a good in terms of other goods. It's the price of running shoes in terms of burritos. If I wanted to buy a pair of running shoes, I'd have to give up the ability to purchase 10 burritos, right? Think about this mathematically. If I gave you $40, how many running shoes could you buy? One pair. Or with that $40, how many burritos could you buy? 10. You face a trade-off, right? I introduce relative prices here because they measure a trade-off, but it's a trade-off in terms of buying goods. 10 burritos. You'd give up 10 burritos in exchange to be able to buy one pair of running shoes. In a sense, the price of a pair of running shoes is 10 burritos. So why do I do this here? Because again, this story of comparative, this story of comparative advantage, when we calculate the comparative advantage, notice that the units on this thing look a whole lot like what we have in terms of these relative prices. It's just the relative prices are about consumption, whereas these opportunity costs earlier that we calculated were the opportunity cost of production. This is the trade-off that we face in terms of production. Lastly, we could talk about a couple of the different assumptions that are built into our model. Number one assumption is this constant opportunity cost, right? So the way that you see this is that we see the opportunity cost or the production possibility frontier drawn as a straight line, right? That makes our math a whole lot easier, and we can easily calculate things. Let me switch that X and Y. We can easily calculate things, but in reality, in practice, in the real world, many times a production possibility frontier is going to have a bowed out shape to it. It'll look something like this. This bowed out shape to it, maybe that was a little bit too boxy. This bowed out shape of this production possibility, I like that one better. Bowed out shape of the production possibility frontier. It might be a little bit more realistic, but my goodness, does anyone feel comfortable coming up with an equation that would describe that line in blue? Don't worry, I wouldn't either, right? I mean, we could do it, but it wouldn't be the most natural thing. This y equals mx plus b linear format does a lot easier job of mathematically showing this relationship. This line in blue might be more realistic. So what's going on here? If you recall, right, the slope of this production possibility frontier is the opportunity cost of the thing that we're measuring horizontally. So what happens as we produce more and more and more x? What happens to the slope? It becomes more and more negative. What we're saying is that in the real world, the way that many things operate is that the more you do of something, the more x you produce, the higher the opportunity cost of producing that thing. That is, in real life, the way that many opportunity costs actually develop. We make a simplifying assumption that it's a constant opportunity cost, when in fact, in real life, it's probably an increasing opportunity cost. To help you think about this, we can think about, my goodness, are you getting ready for the first test in this class yet? Right? I can't remember how far into the future it is, but you've got a little bit of time, right? Could you find an hour between now and then to study for this test? So what I'm thinking about is studying. You are figuring out a way to study. I'm not looking at X, but I'm looking at studying. What I'm going to assert is that the opportunity cost of studying is going to get higher and higher the more studying you do, right? What would you have to give up in order to find your first hour of studying, right? You probably have busy lives, but you probably have a little bit of downtime where to fit in that first hour, you're probably not giving up something too valuable. Maybe it's a little bit of downtime, a little bit of relaxation. How about finding a second hour of studying? How about a third hour of studying, or a fourth, or a fifth? Or what about your 10th hour of studying, or your 20th hour of studying, right? By the time you're studying for 20 hours, what's it going to cost you to find a 21st hour in your life to study for this? Then you're probably giving up something really, really valuable, right? What I'm arguing is that the more you do of something, the more costly it the more costly it is to do additional units of that thing. That's what an increasing opportunity cost is. Again, it's more realistic, it's more difficult mathematically, and so we oftentimes make this simplifying assumption of a constant opportunity cost. Here's the important part. Remember David Ricardo's punchline? His punchline was that trade made both sides of this transaction better off. That punchline, it doesn't change if we add this more complex increasing opportunity cost. So by adding complexity to our model, it doesn't change the outcome. Or removing the complexity from the model, it doesn't change the outcome, right? When we've got the choice between a complex model or a simple outcome, our life says we should always go with the simpler explanation. Two more assumptions in our model that we want to talk about real quickly. So the first is insignificant transportation costs. So what are transportation costs? Those are the costs of getting goods from one place to the other, right? So we're thinking of many goods are manufactured in a different place where they're actually purchased, right? And there's this whole area of management that some of you may be interested in called supply chain, where you figure out the best and most efficient ways to move your goods through the system, through production, manufacturing, distribution, all the way to customer, all of those things, right? So transportation costs, we got to move goods around. So the basic argument that David Ricardo makes is that if we have two countries, country A with an opportunity cost here, and country B with an opportunity cost here, opportunity cost, not OB, opportunity cost here for country B of good X, that David Ricardo's advice is, hey, this country right here, this is the producer that should be producing goods and services. Why? Because they can do so at a lower cost, right? That lower relative cost of the opportunity cost says that country A or trader A is absolutely the one who should do it because they can do it at the lowest cost. What's not in our model whatsoever is anything about transportation costs, right? So what I'm going to do is I'm going to add a story about transportation costs. If we've got transportation costs, and those transportation costs look something like this, right? So for country A, this is their transportation costs, and for country B, this is their transportation costs. We don't know, but there's something about country B where their maybe it's their infrastructure, maybe there's proximity to railroads or other forms of distribution, proximity to highway system, something like that, right? It looks like now when we add in these small transportation costs for country B, yeah, their opportunity cost was pretty large, but their overall cost looks like it's a little bit, right? So in green, we can say their overall cost is a little bit less than the overall cost of country A because it looks like country A has these huge transportation costs, right? I think about this a lot, like Hawaii, for example, right? They're a pretty remote location, and that's part of the reason why goods are so expensive there, right? Is because there's just such tremendous transportation costs in getting goods and services to the more remote locations. So, David Ricardo's advice is whoever is the lowest opportunity cost, that's the trader that should be producing the good. In black, which of those countries has a lower opportunity cost? It's the one over here. But when we factor in transportation costs, this first trader had such high transportation costs. That's not the way that, from a society perspective, where we'd be most where we'd have the best outcomes by producing from country A. Rather, it might be better to have country B do it because they have the much smaller transportation costs, even though they have the higher opportunity cost, right? So again, our model initially assumes that we have insignificant, basically zero, transportation costs. If those transportation costs are significant, then it can fundamentally undercut David Ricardo's punchline that trade can make both parties better off if they find their opportunity cost, specialize in what they're relatively good at, and trade with other people. Lastly, one of the assumptions that's built into our model is phrased like this. Resources can be transferred between production without cost. All right, so there's a lot to pick apart there. What are resources? Again, our resources are our factors of production. Let's go back to these farmers real quick for a second, right? What are their factors of production? What are they producing? They're producing corn. They're producing soybeans. There's some, their factors of production would include land, labor, and capital. Can we take those factors of production of land, labor, and capital and easily transfer them between production, right? Land, labor, and, I know I was missing one, capital. Can we easily take that land, labor, and capital and switch it between producing corn and producing soybeans, right? Well, let's think about that for a second, right? Land, that's a pretty easy factor of production that we can switch from one thing to the other. So that's actually probably not that big of a deal, right? How about capital? Some of the machinery. Are there commonalities in the machinery and the raw materials that are used for producing corn and soybean? Yeah, there's some. We can also take that machinery, we can sell it on the market and buy other machinery to switch production from corn to soybeans, so that's not that bad. How about labor? Can we easily take the labor that was used to produce corn and instead have that labor produce soybeans? Sure, that's not that big of a deal, right? That's not really that big of an assumption. But I go back to the beginning, right? We said that this story of trade is not a static story, that it's a dynamic one. We can think about it through time, right? So we've got, and as the example that I used, it was a bunch of textiles in North Carolina, right? They used to do a whole bunch of textile production. They had this great opportunity cost, this comparative advantage in producing textiles, and now that production has gone somewhere else, right? Well, according to this model, right, let's take out corn and instead let's put in textiles. And now what does North Carolina produce? They produce a whole lot of biotechnology. That's a big thing that's going on in North Carolina right now, right? A lot of different places, including North Carolina. Can we easily take the labor that used to be involved in textile production and now easily convert it to biotechnology production? Our model assumes that those resources can be transferred between those two different productions without cost. Is there a cost to getting our labor from textiles into biotechnology? Think about who that labor is, right? That's individuals, that's people. They're going to need some retraining. There's maybe some mental stressors, mental health cost associated with having to switch careers, having to go back and retrain yourself at, when you're in your 40s, trying to fit a new career and all of the uncertainties that come with starting into a new job, all of that, right? So no. Our model assumes that all of those things, those very real human costs that happen when trade changes, when opportunity costs change, when comparative advantage change, our model just assumes, nope, people can easily just on a dime just switch to a new industry, when that's not the case, right? That has some real significant costs to us, and we ignore those costs in this model. And so those are some assumptions. Again, some of these assumptions are a little bit more critical and have an impact on the punchline to David Ricardo's models. Others, the other assumptions, they kind of fade into the background, and they're just simplifying to make our life easier.